So, my name is Ernesto and today I will explain you the conversions. The first problem is 825 meters per second to kilometers per hour. First you have to know how much is 1 kilometer to meters and 1 hour to second. After this, 1 kilometer is equal to 1000 and 1 hour is equal to 3600. After that, you have to accommodate in a way that you can eliminate meters and only the kilometer remains. So we put the 1000 meters in the lower part and 1 kilometer in the upper part. In this way, the meters are eliminated. The seconds, but instead of putting 3600 seconds down now, they will be put up and 1 hour down to be able to eliminate the seconds. Then you divide the 825 between 1000 and multiply is by 3600 and that gives you 2970 kilometers per hour. We have to convert 8 miles per hour to meters about seconds. First, we have to accommodate a mile at the bottom and 1.609 meters up to eliminate the miles. At 2 hours, we have to put 1 hour up and 3600 seconds down. After that, we multiply 80 by 1609 divided it by 3100 and the result is 0.0035 is 9000 square meters to square centimeter. We know that 1 square is equal to 10,000 square centimeters. After that, we have to divide 10,000 by 9,000, so that gives us 0.9 square meters.
Hi, I'm Sergio, and I'm going to teach you some problems with different type of vectors. We start with two vectors looking at the same direction, in this case the north. So we, in this case, just have to sum, like 5 plus 15, and the result is 20 to the north. Now we have two vectors in opposite directions. In this case, we have to subtract the lower to the biggest one, resting 10 in this case, and we put the direction that have the bigger vector. For this type of vectors, we need to find the distance and the displacement. For this, we need to replace the vectors, getting like this. As you see, we form a triangle with a new vector named resulting vector. This is equal to displacement. To calculate the resulting vector, we use Pythagoras to get the hypotenuse. This is valid thanks to the triangle that we construct with the vectors. For the distance, we just have to sum the two initial vectors. For these vectors, we need to find the square components that are x and y. For this, we need to use our calculator. For the letter x, we need to write the magnitudes, in this case 30, and then the cosine of the angle, in this case 25, finishing like 27.18. For the letter y, we need to do the same, but changing the cosine by sine. And then we have the y is 10.56, like we have here.
Now we are going to solve some problems about uniform linear motion and accelerated uniform linear motion. An airplane moves at a speed of 998,000 meters per second. What is the distance traveled in 30 seconds? The airplane has a speed of 998,000 meters per second, and we want to know how much distance it had covered after 30 seconds. The formula says that distance is equal to times velocity. And the procedure is 30 seconds times 998,000 divided by 3,600 seconds. And the result is 8,316 meters. A car travels at a speed of 20 meters per second, is thoroughly braking and stops at a time of 5 seconds. Determine its acceleration and the distance it travels before stopping. The initial velocity is 20 meters per second, the final velocity is 0 meters per second, and the time is 5 seconds. The formula is acceleration is equal to final velocity minus initial velocity divided by time. And now for the procedure, we do 0 meters per second minus 20 meters per second divided by 5 seconds. And the result is minus 4 meters per second squared. And now for the distance, the formula is final velocity plus initial velocity divided by 2 times time. The procedure is 0 meters per second plus 20 meters per second divided by 2 times 5 seconds. And the result is 50 meters.
Hello, my name is Cesar Hernandez, and now I'm going to explain you a free fall problem. The problem is, a freely dropped body reaches the ground with a velocity of 29.4 meters per second. Determine A. the fall time, B. the height from it was dropped. The data that we gather in the problem is final velocity equals to 29.4 meters per second. The formula that we used to gather the time was final velocity equals to gravity multiplied time. We replace the data, so the final result will be the result of 29.4 divided by 9.8. Now 9.8 is the official value of the gravity, so the final result was 3 seconds. The previous problem, now we can do the operation about how to gather the height. So the formula that we used was J equals to the final velocity divided by 2 plus time. Then we replace the data, so the final procedure was 29.4 divided by 2 multiplied 3 seconds. So the final result was 42.1 meters. The previous procedure, now we know that the fall time was of 3 seconds and the height from which drop was of 42.1 meters. Next problem is upward vertical throw. The problem is, a ball is thrown upward vertically through a device from the floor. It collides with it 3 seconds later. A. What was the ball velocity when it was thrown? B. How high did it reach? The data that we gather in this problem is 3 seconds. If we want to know the final velocity, we have to use the formula of final velocity equals to gravity multiplied time. So we replace the data with 9.8 multiplied 1.5. You ask, how did we get 1.5 seconds? Well, we only divide 3 by 2. So the final result was 14.7 meters per second. The formula that we used to gather the height was gravity multiplied time to the square divided by 2. We only replaced the data and the final result was 11.025. Then the final result was velocity equals to 42.7 meters per second. It was reached was 11.025 meters.
Hi, my name is Kevin and I'm going to talk about the horizontal motion and parabolic motion from the stage 4. So the first problem is about horizontal motion, and it tells us that a stone is launched horizontally with a velocity of 25 meters per second from a height of 60 meters, and it wants us to calculate the time when it reaches the ground, the vertical velocity at 2 seconds, and the distance when it lands. So for the time I used the formula that is the height is equal to the gravity or the acceleration times the time squared over 2, and with a substitution it ends up being 60 is equal to 9.8 times the time squared over 2, and with an isolation it ends up being time is equal to the square root of 120 over 9.8. and the result is time is equal to 3.5 seconds. So for the velocity at 2 seconds, I use the formula that is final velocity of y is equal to the gravity times the time. So with a substitution, it ends up being final velocity is equal to 9.8 meters per second times 2 seconds. So we cancel the seconds of the time and the seconds square, and we get final velocity of y is equal to 19.6 meters per second. And for the total distance, I use h is equal to b, h the velocity, the horizontal velocity times the time, and the distance is equal to 25 meters per second times 3.5 seconds, and we cancel the seconds, and so we have that the distance is equal to 87.5 meters. As for the parabolic draw, it wants us to calculate the range, the time of flight, and the maximum height it can reach with a velocity of 400 meters per second and an angle of 40. So for the range, I use the formula that is range is equal to the velocity square sine of 2 times the angle over the gravity. So the range is equal to the 400 square sine of 2 times 40 over 9.8, and solving that a little bit to make it easier, we have that the range is equal to 160,000 the sine of 80 and over 9.8, and the value of the range is 16,078.49 meters. So for the total time, we have this formula that is total time is equal to 2 times the velocity times the sine of the angle over the gravity. So we make the substitution, that is total time is equal to 2 times 400 times sine of 40 and over 9.8. So solving it a little, we have that total time is equal to 100 sine of 40 over 9.8, and the total time is equal to 52.47 seconds. And for the maximum height, I have maximum height is equal to the square of the velocity times the sine of the angle over 2 times the gravity. So with a substitution, we have that the maximum height is equal to the square of 400 times the sine of 40 over 2 times 9.8. And to make it a little bit easier, we are going to do this first. We're going to multiply 2 times 9.8, and it gives us to 19.6. So you put in your calculator that the square root of 400 times sine of 40 degrees over 19.6, because I think it's better to understand it and to get a more accurate value. And so for the value of the maximum height is equal to 3,372.8 meters.